In this lesson, we are going to be talking about the remainder theorem. So, just as a review, we're going to look at methods for dividing polynomials. Now, likely the only method that you've seen so far in your pre-calculus experience is this idea of canceling. So, you learned in grade 11 how to factor. Actually, you learned it in grade 10 as well, but how to factor. And if we have x squared minus 64 divided by x plus 8, we could factor this on top to be x minus 8 times x plus 8. And when we divide it by x plus 8, we see that these terms cancel. The same can be said for example 2, 3x squared minus 13x minus 10. When we factor that, we get 3x plus 2 and x minus 5. And so again, we have x minus 5 on the top and bottom that cancel. Now, another method that you can use for dividing polynomials is long division. So some of you may have learned long division when you were in elementary school. And what I'm going to tell you is that long division for polynomials is not the most efficient method. So I've included the method in your notes for you to take a look at. If you're familiar with long division, you should be able to follow along with this method. If you're not familiar with long division, we're not going to worry right now about using it for polynomials, because synthetic division, which is the third method in your notes, is actually much more efficient and basically takes the process of long division and just simplifies it so that we only use the coefficient. It makes the process simpler, faster to write, and much easier to work through. So I'm going to show you an example of synthetic division. And I'm actually going to write it out. So these are in your notes, but I'm going to write it out as I go, just because looking at it in the notes, you might not be able to quite follow what I've done. So in synthetic division, basically what we're going to do is we are going to use our coefficients. So when you're doing synthetic division and you're dividing a polynomial by a binomial, the first thing that you need to do is you need to rewrite your polynomial in descending order. So you need to rewrite it with the degrees in descending order. So 2x cubed plus 3x squared minus 2x plus 5. And that's being divided by x minus 1. Then what we're going to do is we're going to take those coefficients and we're going to write them in our little division box. And within this, what we're going to do is we're going to take all of those coefficients and we are going to work on our division. So the key here is that these coefficients must be in descending order, and also notice here that I have a coefficient for each term. So I've got x cubed, x squared, x, and my constant. If I was missing a term, so let's say that there was no term with an x in it, you would want to include 0 in your synthetic division. So you need these to be in descending order of their powers. And what I'm going to do is I'm going to take this x minus 1 and I'm going to end up dividing, or using, 1 on the outside of my synthetic division. And in order to do synthetic division, the first thing you're going to do is you're going to bring down your first coefficient. Like I said, if you're familiar with long division, this is very much related to long division, this process. Once you bring down your first coefficient, you're going to take that coefficient and you're going to multiply it by 1. So 1 times 2 is 2. Once you've done that, you're going to add. So you're going to add these two numbers, which gives us 5. And you're then going to repeat the process. Multiply 5 times 1, that's the next number, and then add. So negative 2 plus 5 is 3, and then 3 times 1 is 3, and add to get 8. Now right now this just looks like a whole bunch of numbers, but we need to figure out what these numbers represent. So what these numbers represent is this end number is our remainder. So when we're doing division, remember, if something doesn't divide perfectly into the other, there might be a remainder. And in this case, the last number is always the remainder. These other numbers can be rewritten. Actually, I'm going to write this out a little differently. So we took 2x cubed plus 3x squared minus 2x plus 5. And what we're trying to do is rewrite this. This is our beginning step in factoring these polynomial functions that are higher than degree 2. So this can be rewritten as x minus 1, because that's what we've divided by, times these three numbers here represent the coefficients in our new trinomial. So 2x squared plus 5x plus 3. And this has a remainder of 8, so we would also have to add 8. Now this makes a little bit more sense when we work backwards. If you were to expand this and multiply this all through, x times 2x squared times 5x times 3, and negative 1 times 2x squared times 5x times 3, and then add 8 and simplify, you would get back to this original function. Think of it like way back when you were learning about multiplication and division, and we know, for example, that 5 times 5 is 25, right? So then we know that 25 divided by 5, I should have chosen a different number, not a perfect square, but we can rewrite these as multiplication or division. This is similar here. So I can say that 2x cubed plus 3x squared minus 24x plus 5 divided by x minus 1 equals 2x squared plus 5x plus 3 with a remainder of 8. Or, if I write it as a multiplication, I can say 2x cubed plus 3x squared minus 2x plus 5 is equal to x minus 1 times 2x squared plus 5x plus 3 plus my remainder. So let's focus on this synthetic division again, and I'll show you another example. So you can see in your notes, that's written down for you. Let's look at the next one. So in this case, my coefficients go from 4, 3, 2, 1, 0. These are already in order. So I can go ahead and take those coefficients and write them in my little division box. Now here I'm dividing by x plus 2. So I'm going to use minus 2. Okay? So I'm going to use minus 2 here, bring down negative 4, multiply, and add. Multiply, and add. Multiply, and add. Multiply, and add. So I have a remainder of negative 55. So if I rewrite this out, I can say that negative 4x to the power 4 plus 2x cubed plus 3x squared minus 4x plus 5 is equal to x plus 2, plus 2 times, now you might be wondering, how do I write this next polynomial? Well, the degree in the question that we started with was 4, and we've divided it by x plus 2, 1x. So we've taken 1x out of here. So that means that this is the coefficient negative 4x cubed plus 10x squared minus 17x plus 30 and minus 55 on the end for our remainder. So remember, this is going to be 1 less than what we started with because we divided by 1x. So that's synthetic division, and we use synthetic division to be able to factor these polynomials that have a degree higher than 2. Oops, if we look at the next page, my pages are all out of order here. There we go. If we look at the next page, I've shown you exactly this. So we call this the division statement. So after you have done your division and you go back and you rewrite this all out, basically almost in factored form, we could factor this further. Okay, we're writing a division statement. So we can rewrite the function, whatever it was we started with, as being equal to whatever we divided by times the result, and then add the remainder. Okay? Now the remainder theorem tells us whether a polynomial is divisible by the binomial. So if you recall, when you're learning, again, basic multiplication and division, we know, for example, that 24 is divisible by 6, because when we divide it, we get a nice whole number. It equals 4. Whereas if we had 24 divided by 5, this would not be divisible, because in this case, this equals 4 with a remainder of 4. Or if you did it in your calculator, it would be 4.8, which means that 24 is not divisible by 5. So the same is true for polynomials. If there's no remainder, it means that it is divisible, whereas if there is a remainder, it's not divisible. Now, our remainder theorem says that if we are trying to divide by a binomial, we can determine what the remainder will be just by plugging in our value of a, which comes out of the binomial. So this is going to make a lot more sense when you look at an example. So if we determine the remainder when this polynomial is divided by each of the following binomials, the remainder when this polynomial is divided by x minus 1 will be equal to whatever this polynomial equals when we plug in x equals 1. So I plug in x equals 1 for all of the x's, simplify, and evaluate. So the remainder would be 20, which means that this polynomial is not divisible by this because it has a remainder. If we take this polynomial and divide it by x plus 3, we can determine the remainder by plugging in negative 3 for x, so the opposite sign. And in this case, we get a remainder of 0. That means that x plus 3 is a factor of, or can be evenly divided into, our polynomial. And we're going to talk about the factor theorem in the next lesson. Finally, in example 2, just an application for you. So it says the volume in cubic centimeters of a box is given by this polynomial, 2x cubed plus x squared minus 27x minus 36. The height in centimeters is x plus 3. What are the possible dimensions of the box? So remember that volume is equal to length times width times height. So in this case, we know that the height is x plus 3, but we need to figure out what the other possible dimensions are. Essentially, we're looking for length times width times height, and we know that the height is x plus 3. So we need to figure out what are the length and what are the width so that when I multiply these out, I get this polynomial. Essentially, we're looking to factor this polynomial. So if I take my volume, now I should have written the length here. This is equal to volume. So if I want to solve for L times W, I can take my volume and divide by H, which is what I've written over here. Take my volume function and divide it by H. So here is my volume function here. I've chosen to use synthetic division, so I plugged in 2, 1, negative 27, and negative 36, and I'm dividing it by my height. Remember, in synthetic division, we take the opposite sign, so negative 3. In synthetic division, I bring down the 2, multiply, and add. Multiply to get 15, and add, multiply, and add. And this works out wonderfully because I get a remainder of 0. So this means I can rewrite my polynomial as x plus 3 times 2x squared minus 5x minus 12. And then this here is just a quadratic, and we have lots of experience factoring quadratics. So when I factor this, and you can use whatever method you'd like, split the middle I think is the most common, you get 2x plus 3 and x minus 4. These are the possible lengths and widths because we have to have x plus 3, which was the height, times two other binomials to get our volume. So these are the possible binomials.